Today is November the 4th, 2020, and my guest today is Grazia Vittadini, the CTO at Airbus. Grazia, thank you so much for spending some time with me today.
Thanks for having me, Addison. It's a great pleasure to have the opportunity to exchange again after Paris Air Show. That was the last time we saw each other.
It's like 100 years ago,
so
it feels. So the reason I wanted to speak with you today is the obviously the recent announcement from Airbus about the whole hydrogen thing. It's quite fascinating. So why has Airbus decided to make the move towards hydrogen now? So did COVID have anything to do with this, or was it may have been pre-COVID thinking?
Well, you know, Addison, at Airbus, the reduction of CO2 emissions as a whole, and more generally, the improvement of the environmental performance of our aircraft has long been a very important requirement for not only the design, but also the manufacturing of any new aircraft. In this sense, our ambition to bring the world's first zero-emission aircraft to market by the mid-2030s has not been significantly influenced by the pandemic. As to why now, well, the aviation industry, which includes, of course, us, Airbus, did commit to quite industry-wide and ambitious decarbonization targets which cannot be achieved just using the technologies currently in our portfolios. And we believe strongly that both alternative propulsion systems and alternative energy sources, which we're developing via the zero-emission aircraft project you just mentioned, will push the boundaries of aircraft technologies in the right direction to really significantly help reduce emissions in all future aircraft. Aviation, as you know, is a very long-term industry, and we are convinced that we need to act now to ensure that the future of the industry as a whole is a sustainable one.
It's intriguing that you've come up with, or Airbus has come up with this idea, because it would seem to me that you would be producing in the mid-30s, let's say, an airplane that is probably going to have higher op costs than what we have today. And what kind of an impact would that have on operators? I mean, this is an industry that is constantly chasing lower costs. Do we see a situation where this technology, the new engines, the new fuel, could help at least match where we are today?
Well, costs are definitely a parameter, and costs for our operators, for our customers, are definitely a parameter we are embedding into the equations when it comes to development of new technologies for zero emissions. And certainly today, both the cost of for the production of green hydrogen or the cost for the production of sustainable aviation fuels are nowhere near the competitiveness of kerosene.
Right.
But that's also why it's important to continue working in this direction, not only as industry, as an aviation industry, but as much as possible across industries, because as more industries will really start harnessing on the potential of hydrogen, then we know it, we've seen it in other cases, the costs are due as we scale industrially the production of green hydrogen, the costs will go down.
Right.
So it's important to really harness on the potential of these technologies from a very broad perspective. No industry, no company, no nation will do it on their own.
Okay, now you had a fuel cell technology partnership with Elring-Klinger. Is that still active?
Definitely, definitely. So Elring-Klinger is a worldwide leader when it comes to fuel cell technology. And as hydrogen technology is really key to our ambition into developing the world's first zero-emission commercial aircraft by 2035, we are exploring a variety of configuration and hydrogen-specific technologies, which include the use absolutely of hydrogen fuel cells to generate electrical power. And ElringKlinger has been actively pursuing research and development in that area for, well, more than 20 years. They're serving the market currently both as a system and as a component supplier. And they will provide us with the relevant expertise in design and manufacturing of fuel cell technology or fuel cell stacks.
Okay.
We've established a company, so there's a joint venture, a new legal entity, which will really serve as independent research center for Airbus in the area of fuel cell technology. So it's a very promising partnership.
So as Airbus works towards zero E, are there other partnerships? Are there any other partnerships you can talk to us about?
Well, I can speak about the rationale behind partnerships. For instance, the one with ElringKlinger, so which are really have as common denominator the need to better understand hydrogen as a whole. So also really as a gas or liquid. This is the fundamental enabler for us to be able to achieve our ambitions in terms of zero E. It's you know, again, if we generate hydrogen from renewable energy, for instance, through electrolysis, hydrogen allows to generate no CO2 emissions, and it can really, as I mentioned before, be a solution for several industries to meet the climate neutral targets, which are not exclusive to aviation, right?
Okay.
So we are exploring several hydrogen technologies, not only hydrogen fuel cells, we're looking also, for instance, into direct combustion of hydrogen through modified gas turbines. Now, as I mentioned before, no company will be able to manage this alone. So of course, we're looking into
several partnerships.
Several partnerships.
You mentioned, Grazia, the mid of the 30s for an airplane. When do you think you might have a demonstrator? Sooner than that, I would hope, right? Well,
we are into several different demonstration roadmaps already now, which we are progressing on, really with the intent to have by let's say mid of this decade already some very tangible results in the sense of which is the most promising technology, hydrogen-based technology, and which configuration would we be then implementing this technology on. So yes, absolutely. As usual, as you know, in our industry, safety comes first, always.
Right.
And as such, whatever technology roadmap we're pursuing has several key milestones which do imply the demonstration of what we're developing.
I would imagine that this process that you're going through is not unlike what we've seen traditionally in this industry, that engine technology is really the sharp end of the spear in moving things forward, right?
Well, it is one of the many contributions to that zero emission ambitions. So the propulsive type of evolution or revolution around zero emission. It's typically the component which we've been also leveraging on until now, right? Every new Airbus aircraft offers on the market, offers significant benefits in terms of reduction of fuel burn up to 20-25%, depending on the model. And this is largely thanks to an evolution in the propulsive system. But it's not the only component.
Right.
We're looking into still, of course, advanced materials. Autonomy has also a component, a role to play when it comes to savings. Sustainable advanced materials I mentioned, and the whole design, manufacturing and service digital backbone will also contribute to reducing our own industrial footprint. And let's not forget that once we open the door to alternative propulsion, we free ourselves from the constraints of a traditional architecture, as we've seen flying since the Wright brothers' times, right? Fuselage, empennage, and wing.
Right.
And for instance, the blended wing concept we have presented amongst other three on September 21st represents exactly this opportunity. Once you go into hydrogen and you look at alternative means of propulsion, you are also free to explore revolutionary architectures.
You actually led right into my next question, which is that you guys offered 3 layouts. Any particular reason why those 3 and maybe more than 3 are under consideration? It was just interesting that obviously the blended wing was the biggest eye catcher.
Yes.
Can you tell us anything about that, please?
Well, with the unveiling of these 3 concepts, we've tried something which normally you'd see very much in the automotive industry, the idea of concept cars, right? Which are unveiled to underline what the intent of a company is and also inspire and motivate engineers going forward into really working to the ambitions of a company. So we've really thought about how hydrogen as common denominator together developed concurrently and coherently with the other technology bricks on our roadmaps. What would it mean when we'll start looking into putting all that into a product?
Right.
And so typically, you know, in our product portfolio, you'd have the typical turbofan design with a range, let's say, of 2,000 plus nautical miles, powered by hydrogen in our concept rather than jet fuel, which could go and operate in its evolution even intercontinentally, right? With a 200 pax maximum capacity. Right. The turboprop has, let's say, 100 passengers as maximum capacity. Also with hydrogen combustion in a modified gas turbine engine type of configuration, with a target range, let's say 1,000 plus nautical miles. So perfect option for more short haul type of trips. And then indeed the blended wing body, which follows the concept we've demonstrated on scale with Maverick. We have several concepts we're testing first at lower scale before considering their validity as architecture, really, for our aircraft. And this blended wing body, which was an absolute attention catcher, really demonstrates that how, thanks to the wide cabin layout, we can consider multiple options for hydrogen storage and distribution. For the time being, in this specific configuration, we're looking at cryogenic storage tanks underneath the wings. And for this configuration, we have packs capacity and range as for the turbofan type of concept. So it's exciting concepts, which we will be refining in the course of the next years. Where, yes, as we already discussed before, what's really fundamental is the technology brick constellation behind these concepts, and of course the demonstrators. The ambition, as I mentioned, is to have results by 2024, 2025, in the sense really decisions which will allow us to make technology and product launch considerations.
Just before we jump away from these airplanes, I think for one of the things that really caught my eye was having a turboprop put forward in an Airbus presentation. So I guess ATR clearly is part of the planning in this process, or is Airbus suggesting now that it would go down the turboprop route without ATR?
Well, as you know, we have 50% of ATR, together with the other 50% is owned by Leonardo. So we are definitely conversant with ATR, but there's also other partnerships we are exploring and which are available to us when it comes to that segment. So it's definitely one of the many options we're exploring. Let us not forget that also there's an ambition at European level within the clean aviation joint undertaking ambition to one of the three pillars of the joint undertaking, the evolution of the clean sky, of Clean Sky 2, what we call clean aviation. One of the three pillars is around really the technology developments linked to the regional turboprop concept. So there will be many ways to explore that configuration.
You alluded to my next idea, or my next issue that I wanted to talk about. You alluded to a little earlier. What about cruise? Is Airbus still thinking about single pilot ops? Is that a consideration in the new technology?
Absolutely, absolutely. So our ambition in terms of automation and autonomy roadmap remains unchanged. The developments in the sense of single pilot operations are rather independent of the Zero-E initiative and vice versa. We're exploring several avenues with the intent really to continue improving flight safety and making extensive use of automation and connectivity. Single pilot operations is one of these solutions. Definitely, one of the rationales motivating us to progress in this direction before the crisis was the exponential growth of air traffic, which we want to remain optimistic and continue assuming that we will be back to where we were in the next years. And in China, the Chinese situation on the domestic market gives us good confidence that
Right.
there will be a ramp up back to some sort of normality.
Right.
Yet let's not forget also that it is a concept which will enable our customers, the operators, to reduce significantly the cash operating costs. So there's different drivers between this type of development. The principle behind it is that the airplane itself is mostly autonomous, whilst the human component continues focusing on managing the mission.
Right.
And the strategic decision making will still be 100% with the human component, and autonomy is rather to support. We can envisage starting implementing the first demonstrations of this technology maybe on cargo flights before going into passenger operations. Another option we're looking into, which could be also tested on a shorter term on purely commercial flights, is having one single pilot at the controls during the cruise phase. Not end to end. This would enable crew numbers to be reduced for very long flights with an improved level of safety according to our assessments. There is no specific entry into service for these solutions. We are developing, we are maturing them. I think my opinion is that by the end of the next decade, it's absolutely feasible. It's to be expected. It's to be expected. We will see the first in-flight applications.
We've mentioned so far that the fact that hydrogen is cleaner, and that's obviously a huge advantage. Do we see is there any impact that you can share with us on perhaps noise? For example, would a turbine running on hydrogen sound different than running on fossil fuel? Is there any clue how that would work?
Well, what we can say today is that hydrogen is safe. It has an interesting versatility. It's lightweight. It has a very high energy density. It's almost 3 times better than jet fuel. We know that it emits no CO2 when combusted, when burned. We know that it produces water and vapor in the case of direct combustion. And this, for us, solidifies really the conviction that hydrogen is an exciting zero-emission technology pathway we want to continue exploring.
Right.
When it comes to engines, well, we're looking at the potential again of hydrogen direct combustion. It's with the charm of considering platforms, aircraft with these type of engines on board as easier to hybridize with fuel cells instead of batteries once we have hydrogen on board, right? Once you have it on board, why would you need batteries associated to electrical power generation?
Right.
That's the charm of it. And all these solutions require working hand in hand, of course, with engine manufacturers. They will have a huge role to play in bringing hydrogen to commercial aircraft. Now, whether these aircraft at the end are quieter is, in my view, premature to say.
Right.
It will definitely be a parameter for us to keep on our radars and to test continuously as we progress in the development of these technologies. So noise emissions are absolutely a fundamental parameter, which we've also been substantially improving with each new model we bring to the market.
Okay. You just mentioned batteries, so that was my last question. Really was the Efan program. Is that now kind of done at Airbus? The Efan thing?
The Efan X with its predecessor Efan, which, let's remember, flew across the channel as a first worldwide, together with other platforms such as, for instance, Vahana on the urban air mobility side. These projects were born as demonstrators. Okay, there was never an intent to make products out of them. We use demonstrators to accelerate our learning on specific technologies. And in this sense, Efan X played a fundamental role in our decarbonization journey, because it really helped us realizing the potential that electrification solutions can offer to larger applications. We still have initiatives ongoing along the electrification, let's say, roadmap. We have an EcoPulse project running with Daher and Safran, testing distributed propulsion. We have several other urban air mobility projects ongoing. We will have someone joining Airbus soon to lead the electrification and hybridization ambition. We've learned a lot via Efan X, especially on the serial hybrid electric propulsion, which has a lot of potential, but also a lot of limitations. We've learned about managing high voltage systems on board an aircraft, and we learned about batteries, 2 megawatt pack of batteries. It's all indispensable learnings, which we will seamlessly really connect to other R&T portfolio developments. And testing these in our e-aircraft system test house in Ottobrunn. Again, serial hybrid electric propulsion offers possibilities, but also limitations.
Right.
And let's not forget that at some point we will need to certify all this. And the learnings capitalized so far, not only on the platform, but also on the infrastructure, will be key also in the frame of the hydrogen studies we are pursuing.
Grazia, that's all that I had for you today. Thank you so much for your time. I really appreciate you sharing some big things here with us.
Always a pleasure, Addis, and looking forward to the next opportunities.